In session number 1 and session number 2, we have spoken about hydrostatic pressure, stationary fluids, buoyant forces, isobars in static fluids, and how the liquid surface behaves once it is accelerated. Now, today, we are going to talk all about moving fluids. There are some important principles in moving fluids, or what you call it as hydrodynamics, and it plays a very important role. Like, for example, the testing of the shape of a car or an aeroplane. You need to make sure that the shape of your car is aerodynamic in nature so that the resistance is as low as possible. And this setup, this experiment happens in something called as the wind tunnel, and it's also known as the wind tunnel experiment, and you can see those nice beautiful streamlines being formed over the surface of the car. And even the shape of an aeroplane wing, the shape of an aeroplane wing is also aerodynamic in nature. Look at this beautiful streamlines, how they are beautifully moving over the surfaces of a wing. And this is what we are going to talk about. So let's get into the world of moving fluids with me, Shreyas, your master teacher for physics, going live at Vedantu. Welcome aboard, we enthusiasts. Another lovely session over here. Every day at 7 o'clock, you're going to find me over here, and we are going to cover all the syllabus of 11th and 12th in these flash series, so that you are very well prepared before your board exams, before your first attempt of JEE Mains examinations. So it doesn't matter whether you are 11th, 12th or dropper students, you are at the right place over here. We all of us are going to make sure that you are going to excel in your studies. And that's what we promised you, and that's what we are going to do. And if you want to still get in touch with me and you want to follow the amazing stories, amazing quizzes and amazing knowledge I give apart from YouTube, you can definitely follow me on my Instagram handle, and that is Shreyas_Vedantu. So do not forget to check out all the cool videos and updates that I keep posting on my Instagram handle as well. So welcome aboard Satish, Aarti, Science Priya, Sneha, Fida, 17S, Kirito, Selva, Asmi, and so many others out here who have joined for this lovely session. Hello Jumna, hello, welcome aboard everyone. So let's quickly glance through the timetable, but before that, I hope you guys have subscribed. All the students out here who have come here for the first time, or maybe even if you have come for the second time but you have not hit the subscribe button, please hit that subscribe button right away, because you will only get updates when you hit that subscribe button and when you click on that like button out there. So if you have already subscribed, do not forget to smash that like button out there, because only when you smash that like button, YouTube is going to recommend you our videos. And we are also going to get energy, and we are also going to get that motivation from your likes, your lovely comments out there. So welcome aboard everyone. Hello Raj Kishore, you are new, I guess. Welcome aboard. Yes, so let's begin the class. And hello Vemula. Let's glance through the timetable for this particular week. Like I said, 11th standard portion will be generally covered in the first half of the week. So right now, today we are going to do the third part of fluid mechanics. That's the last part, by the way. So hydrodynamics and Bernoulli's equation today. Tomorrow, capacitors. We're going to start with capacitors, session 1, then session 2 on Friday. Session 3, session 4 will be next week, and after that you will have magnetism. This Saturday, special class. You can keep guessing what it is. And do not forget, tomorrow morning 8 o'clock, so it's 8 a.m. tomorrow morning you will have a Menti quiz on current electricity. So come prepared, guys. Let's see who is going to be the winner this time. Current electricity. In case you have missed any of the classes, do not forget to check out all the videos in our playlist. Alright, so let's begin our class. Alright, I hope the Josh is very high, guys. Come on, put it up in the chat box. I want to see if the Josh is high. If you guys are ready to begin the class. Good evening, Aishwarya. Welcome. Hello, Shreya. Welcome aboard. Yes, the Josh is high says Uncharted and Jumna and everyone. Welcome everyone. Come on, let's begin the class. So first let's talk about something called as streamlines. Now, what is a streamline? A streamline is nothing but the path taken by a fluid particle. So, how do you see how fluid particles are moving? You color the fluid. You can add some artificial colors into that jet of air or the jet of liquid. So, let's say for example, a river is flowing and you drop some ink in that river. You can see how that ink will trace the path. That is exactly the path taken by the particles of that river particles. So, understand, streamlines are nothing but the paths taken by particles, and you can see clearly how the streamlines are, and they also point in the direction of velocity, and the streamlines can come closer, they can go far away, and based on that you will see that there is a principle based which is called as the equation of continuity. We'll come to that in a bit. One more thing, streamlines do not intersect each other. Look at that, the streamlines, they do not intersect each other. That's another important property. So let me write all the important things out here. If I draw a tangent, that will give me the direction of velocity. So first important pointer, the tangent to the streamline, gives me nothing but the direction of velocity. That's what it gives me. Second important thing, streamlines do not intersect each other, because if they did intersect each other, that means that point has two velocities simultaneously and you would be in confusion. What is the actual direction? So a streamline cannot intersect another streamline, and what were streamlines? They were nothing but the path taken by fluid particles. Okay, so that's very important. That's something you should know. Okay, we have a honeybee, big visitor. So I had to peacefully let him go outside. All right. Yes, it's a physics student maybe, but it's so sad that I had to shoo him away. So let's get going, guys. Now, the next thing that I want to talk about is the laminar flow versus the turbulent flow. Laminar flow versus the turbulent flow. So, what is the meaning of laminar flow? In laminar flow, you will see the layers of fluid will flow over each other very smoothly. One layer moves over the next layer moves over the other layer. So there are layers of fluid moving over each other. That is nothing but called as laminar flow, like the one you see over here. See, look at the fluid particles. One layer is moving over the other layer. That is called as the laminar flow. Saurav, you're not too late. You're just little bit later than the honeybee. Okay, so anyways, so that's our inside joke now. And what is the meaning of turbulent flow? In turbulent flow, guys, these particles will move randomly. They do not follow any particular pattern like the one you see over here. Like when the river water flows really fast through a narrow passage, you will see the particles get mixed up, they move randomly here and there. So that is the meaning of turbulent flow. So a good example of laminar flow is this liquid out here. Look at the liquid coming out of this pipe. Each layer of liquid, actually these layers are concentric circles. I don't know whether you can visualize it, but try to visualize, guys. Try to use your brains. You can visualize this. There are layers of fluid which are moving with respect to each other. Probably the liquid which is at the centermost part is moving the fastest. The outermost layer might be moving a little bit slowly, just like the one over here. Imagine this was the cross section of that tube. Then the liquid at the center will be moving really fast. The liquid at the end will be moving a little bit slowly, something like that. And the example of turbulent flow, this is how it will look like. The liquid particles do not follow any particular pattern. The flow is completely unpredictable. So this is what turbulent flow definitely looks like. I hope everybody is clear about this. I hope that everybody is clear about this. All right. So very important pointers out here which are coming up. And now the next thing that comes up is the assumptions which are there in hydrodynamics. Now many people know about what these assumptions are, so I'm going to tell you what these assumptions are. Very, very important. Write all these pointers down. First assumption, there is no viscosity. There is no viscosity, because if there is viscosity, then you cannot conserve the energy. So if the drag forces are absent, then understand you can conserve the energy. So we are going to make this assumption that the viscous force, the friction force in fluids is absent. So that's when you can conserve energy. Only then all other laws and principles which we are going to see are valid. That's your first assumption. No viscosity. Second assumption, guys, it's a predictable flow. You just saw how a predictable flow looks like. I just showed you laminar flow and turbulent flow. So in predictable flow, you can predict how the streamlines are if you know initially how they look like. Even after 1 hour, they will look the same. Even after 2 hours, they look the same. So streamlines are not going to change with time. That is the meaning of predictable flow. That means the flow is not turbulent. That is the meaning of that. Saurav, I think you're a little bit late. Hydrodynamics means moving fluid. That's why you should never miss the introduction. Alright, so that's the meaning of that. Okay, moving fluid is hydrodynamics, hydrostatics is stationary fluid. Next, there is no change in density. No change in density means what? The fluid is not compressible. So even when the liquid flows through a narrow passage or when it goes through a bigger passage, it will not expand. In fact, it will maintain its density. So the density remains constant. That means the fluid is not compressible. That's the next assumption. And the last assumption, guys, the flow is irrotational. There have been times where these kind of questions have been asked in CET examinations as well and in BITSAT. So irrotational means that whenever particles of the fluid will move, they do not rotate about their axis. They only translate. So they only translate, they do not have any rotation. So whenever we talk about the energy of the fluid, they only have translational energy, they do not have any spin energy. So there is no rotation of the streamlines. The streamlines are just translating, they are not spinning as they move. So that is a fair assumption, because most of the times when liquid flows, they hardly have any rotational component in it. So these are the 4 important assumptions which are there in hydrodynamics or moving fluids. Now, the next important formula is for a moving fluid, guys, in a pipe or through a cross section. What is the rate at which liquid flows? That rate of flow is given by this particular formula. Q is nothing but the flow rate, that is how much volume flows per unit time. The unit for this in SI is meter cube per second. Okay, this is the SI unit. Okay, but you can also write it as liters per minute and so on and so forth. You can write it in various units, whatever you like, or you can convert it. So meter cube per second, how much water or how much liquid or how much gas flows per unit time is called as volume flow rate. And that volume flow rate, Q dot, or just Q, is given by dV by dt. Please understand, this V stands for the not velocity, this stands for the volume. So this stands for the volume. So dV is the small volume that flows in small time. So a section of that stream comes out in time dt, that is the volume flow rate. That is why meter cube per second, that's volume flow rate. And it is given by the formula area into velocity. This V, small v, stands for the velocity out here. Be careful. And this is nothing but area of the section that we are talking about. So understand what is A and V over here. V is nothing but, small v is nothing but the velocity of water, and this thing will have some cross-sectional area, that is nothing but A. So area into velocity gives me the volume flow rate. Is that understood? This V is not velocity, it is volume, so it is not acceleration. Be careful, Bhargav. Okay, Kirito? Yeah, I think Kirito has explained it. Yes, V is volume, not velocity. Be careful, that is capital V, this is small v. Okay? So it's up to you how you want to write it. Some people might get confused, so I don't mind putting V over L over here to make sure that you know that it is volume and not velocity. Okay? Great, 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 great. Chalo. Let's go ahead. Let's make use of this volume flow rate now. Come on guys. There is a very good problem coming up. Now for that problem I need one equation, and that equation is called as equation of continuity. Now look at this beautiful flow out here and there are so many streamlines, so many particles. These particles are converging here and they are diverging back. Do you see that the flow of the particles is very slow here, but as they come closer they move a little bit fast, and as they go far away again the flow becomes slow. I hope you can see that the flow is very fast here, but it is slow when the area broadens up. And this is what you would see in a river which becomes broad suddenly. Then you will see the liquid is flowing very slowly, but when the river becomes narrow, then you will see that the liquid or the water will flow really fast. This is very well explained by equation of continuity. So it says that whenever liquid flows from different cross sections, the volume flow rate should never change. Whatever comes in should go out. Isn't that obvious? Think about it. So if something is coming inside, that should also go outside. So it is just saying that the volume flow rate is same, in is equal to out. So let's say over here the velocity is v1, the area of cross section is a1. Over here let's say the velocity is v2 and let's say the area of cross section is a2. Then what is the volume flow rate coming in? It will be a1 v1. I just told you what is the formula for volume flow rate. And what is the volume flow rate going out? It will be nothing but a2 v2. So this is your very famous equation of continuity. Very simple. If you know what is the formula for Q, you can easily get this equation. Very, very easy. V is the speed. Now think about it. If the area becomes small, to keep the product constant, velocity will increase. That's why whenever the passage becomes narrow, you will see the velocity will increase. You can see that the product of area and velocity should remain constant. I hope this is very clear. Shall we do some problems? Yes? Are you guys now ready for a very good problem coming up on your screen? I hope everybody has written down everything. Excellent, Raj Kishore, Ranjit, Princey, Kirito, Saurav, Aarti, Fida, Jumna, Uncharted. All right. So let's get going. Yes, Science Priya. Yes, Bhargav. Minions are ready. Very good. So here it comes, minions. If the height of the water in the tank is not changing and the tap water is coming at a speed of 6 meters per second, centimeters per second, and the cross section area is 3 centimeters square here, and this tank has a hole at the bottom and it is going in a mixer kind of an arrangement. Liquid also comes from that side with a speed of 4 centimeters per second, and cross section here is 1 centimeter square. With what speed do you think will the liquid come out from this side? Come on guys. Thank you, Crazy, but you don't have to type it so many times. Even if you type it once, I will read it, don't worry. Thank you, but okay. Please don't put it too many times, okay? Chalo. Come on guys, think about this. What will be the answer for velocity? Let's see who can give the answer really quick. Think, the water is getting mixed here. The water is coming from the tank and from this side. But it is also mentioned that the height of the water inside the tank is not changing. Alright, some people are saying 7, some people are saying 11. Let's see what the correct answer should be. So guys, here is the logic behind it. See, since this height is not changing, this is basically constant, can I say whatever liquid is coming in is directly going over here? As if whatever liquid is falling onto the tank is directly going out. And some liquid is also coming from this side, and both of them are mixing and coming out over here. So can I say the water flowing from the tap plus the water flowing from the right side is equal to the water which is actually coming out per unit time? This is the flow rates which I have equated. So a lot of people might not get how to solve this problem if they have by-hearted equation of continuity. But I did not make you do that. I first made you understand what is flow rate, and then I told you flow in is equal to flow out. Now, if there are two or more pipes, then the equation will change slightly. That's all. So water coming out from the tap has flow rate of A1 into V1, which is 3 into 6. Water coming from the right side is A1 or A2 into V2 is equal to water coming out, which is 2 into that velocity. That's how my equation will look like. 3 6 are 18 plus 4, which is 22. So 2V is 22. Naturally, V will be 11 centimeters per second. That's how you get to the answer. Direction is given VSG. I don't know whether you can see this arrow mark. Probably it has come out really small. There is one arrow mark there. So that arrow mark says, okay, there is an arrow mark over here. That arrow mark says that the liquid is coming towards the left side. Okay, so that's how it is. I hope this is clear. Okay, maybe it was not seen so easily. All right, guys. All righty. So let's get going to the next question now. Oh, no problem, Uncharted. So that's why I showed the arrow mark at the beginning, because I thought most of you might not be able to see it. That's why I showed that arrow mark. Okay, so let's get going. Now, before we go to the next question, let me also tell you guys that, the pro subscription course or the pro subscription offer which we are giving it to you is for your benefit. Say, why are we telling you about pro subscription? You might be like, sir, I can learn everything from YouTube. Yes, you can learn everything from YouTube, but there are times when you feel that, yes, you want to connect with the teacher, you want to connect with your fellow batchmates, you want that feeling of the batch, you want your doubts to be answered, you want the test series, you want assignment, you want the booklet, you want somebody to solve your doubts, you want those special courses, for, let's say for KVPY, for let's say booklet solving and so many other things. So understand, that is why we tell you about the pro subscription. So it's not that, pro subscription, it's not like YouTube we do not teach you everything. We teach you all the things. But you sometimes need that feeling of belongingness, sometimes you need that nurturing, sometimes you need that special guidance, and you want somebody to always push you. So you have those personal teachers and those personal counselors who will guide you through the entire process. That's why we tell you about the pro subscription. And this pro subscription, you get your regular batches. Apart from that, you get all the other benefits like tests, assignments, booklets, micro courses, special courses, and all the other stuff, all the goodies that you get. So the link is given below and the prices are also mentioned, but still let me tell you, for the 11th standard, if you take it for 6 months, it comes to 24,000, but you will get 20% off. And once you get 20% off on 24,000, the price comes to 19,200, which works out closely to 107 rupees per day, which is very affordable considering the factors that you are getting so many things. And the code that you have to use to get this 20% off. So first thing I would like to say, please read everything properly in that link below. See what and all benefits are there. See, talk to other kids, talk to your parents properly, discuss and decide how many months you want to take the subscription for, whether you want it only for 1 month, 3 months, 6 months or 12 months. It's totally up to you. You can try it only for 1 month, and if you feel like continuing, you can continue, or if you don't want to, also you can do whatever you want to do. All right. So the coupon code is SHHPRO, and when you use this coupon code, only then you get the discount of 20%. So make sure that you use the discount coupon, because only then you'll be getting the 20% off. All right, so let's get going. Is there a Pro Lite, Pro Plus? No, there is nothing like Pro Lite, Pro Plus. There is something called as Pro Lite. Pro Lite is all the features except for doubt. Pro Classic is everything plus the doubt. Okay, and Pro Plus is everything plus doubts plus a personal teacher. That's the difference. All right, so that's how it is. Okay, now okay, VK has come little bit late. Yes, VK, you have missed some scenes for sure. Yes, okay, so let's get going to the Bernoulli's principle now. So many of you might have heard what is Bernoulli's principle. So let me tell you what Bernoulli's principle is, and very important pointers out here, so keep making notes. So first of all, this equation is used whenever you have a moving fluid in a pipe-like structure. Sometimes that pipe is not very evident, but you can draw a pipe, imaginary pipe, and then you can apply the Bernoulli's principle. Now for applying Bernoulli's equation, always make sure that you have two cross sections decided on that pipe or that imaginary pipe. So think of some streamlines, think of an imaginary pipe, think of two imaginary cross sections on that pipe. And then once you have decided on those two cross sections, how to decide that, we'll be solving problems, then you'll get a hang of it. Then what will happen is that you can write a very beautiful equation which comes as a result of energy conservation and work kinetic energy theorem. So it's basically energy conservation at the end of the day, and I'll tell you what and all you will need. First thing you will need is the velocity at one end, V1, velocity at one end. Then you will need the velocity on the other side. Alright, so you can assume it if it is not given, V1 and V2. So they might not be equal, remember, because the area of cross sections may not be the same. Then you have to know, or you can assume the pressure on one side, where, see, why will there be pressure? Because when the liquid is flowing, it will be pushing the walls of that pipe. So when it is pushing the walls of that pipe, understand there will be some pressure. So that pressure is the pressure of that fluid. So on this side the pressure is P1, but when it goes here, the pressure might change. It will be P2. Now be very careful, guys. One crazy thing, one common silly mistake is that lot of people say, sir, if I know P2, I also know P1, because if P2 is something, some value, then P1 will be P2 plus rho GH. That is wrong. That is wrong. Why? Because P1 is P2 plus rho GH is only valid when the fluid is static. That formula was completely valid only when the fluid is static. The moment you have moving fluids, then you cannot use pressure at this point is pressure at this point plus rho GH. That is not at all valid. Be careful. Yes. Now, once you have assumed the pressures at two different points, the next thing that you need to do is assume a reference line. Very, very important. Choose a reference line. You can choose it anywhere that you want, and from that reference line, measure the heights H1 and H2. So H1 is the height at which the cross section 1 is from the reference line, and H2 is where the height of the second cross section is from the reference line again. And make sure that these heights start from the reference line, very important, and they exactly go till the center of the cross section. They exactly go till the center of the cross section. So look at that, they have to go to the center of the cross section. Very, very important. I hope everything is clear. Okay? I hope you have written down all these important pointers. First important pointer, P1 is not P2 plus rho GH. Why? Because it is a moving fluid. That formula is only valid for static fluid. That's one point. Second point, always measure the heights from the reference line till the center of the cross section. Till the center of the cross section. Next, these pressures are by the pressures of the fluid on the walls of the container as well as the particles of the fluid. These pressures are the pressures by the fluid on the walls of the container as well as the particles of the fluid. Alright, and last thing, we are going to write the equation. The equation looks something like this. You first put an equal to, and on left side put P, right side also put P. Then you put rho GH on left side, then also put rho GH on the other side. Then put half rho V square, then you put again half rho v square. Last thing, on left side put 1, 1 and 1, on right side put 2, 2 and 2. That is your Bernoulli's equation. Okay? So this is your Bernoulli's equation, as simple as that. So very, very important formula. P1 plus rho g h1 plus half rho v1 square is P2 plus rho g h2 plus half rho v2 square. That's very easy to memorize this. As simple as that. Now each term has a special name. Let me give you that. This P is called as pressure energy per unit volume. This is called as pressure energy per unit volume. Okay? Then this is called as, potential energy per unit volume, and this is called as kinetic energy per unit volume. So what it says is, whatever total energy the liquid has initially, pressure energy plus potential energy plus kinetic energy, will remain conserved even when it goes to the other side. So the potential plus pressure plus kinetic energy will still remain the same. The amounts might vary, one might increase, one might decrease, that's okay, but the total sum will remain constant. That is what this equation says. And we have assumed that density remains constant. You can see that. Remember our assumption, density is constant, so that is why rho is same. Second thing, there is no loss of energy, that's why the total sum of energy before and after is the same. Else, if there were some losses, then you will never see this being equal to. Very, very important. Okay? So this is how you should remember this formula. Write it down: pressure energy per unit volume, potential energy per unit volume, kinetic energy per unit volume. Very, very important stuff. Questions can come directly as a theory point or as problems. Now let's start solving problems so that you know how to apply Bernoulli's equation. Let's begin, guys. Now, very important application, but let me tell you, not many people actually know why the formula comes the way it comes. Many people might have by-hearted that formula, that's okay. But let me tell you today why the formula comes the way it comes. So here is the thing, if you drill a small hole in the tank, alright, which contains some fluid, the fluid is going to flow out. That speed with which it comes out, alright, that speed with which it comes out over here, let me call it as V. This V is called as speed of efflux. This is called as speed of efflux. Then the next thing that you should know, there will be a small opening. That opening has an area A. So A is the area of cross section of that small opening, or sometimes it is just called as an orifice. Area of oops, just one second, guys, my bad. So this is area of cross section of that small orifice. Okay? So that small orifice will be there. Orifice is nothing but a small opening, that's that area. And capital A is the area of the container or the tank itself. So capital A is the area of the tank or the container itself, and this is generally much larger than the opening out here. Generally these openings are like a pinhole, a small hole, so this is generally very large, very important. Now next thing, there will be some range over here. This is R, so this is called as the range of that particle, or sorry, the fluid from the bottom of that container. And once you know all these things, let's imagine how the streamlines will look like. The streamlines will look something like this. It will look something like this. Look at that. These are the streamlines. Are you able to see that? The streamlines are going to look something like this. Nothing will happen at the bottom, only the ones above the pinhole the water will start flowing there. This water will hardly be disturbed, and the streamlines are going to come out like this from here. This is what is going to happen. So it's very important. No problem, VK channel, I understand you have some thunderstorms going on there. No problem. Now choose two cross sections. Choose two cross sections. Hello Shreyas, join in. One cross section will be here. So this is one cross section, guys. And the second cross section will be here. In case you are still not able to see it, I'll draw it here. So this is one cross section, and this is my second cross section. This looks like a basin or a sink, wash basin to me. Does it look like that? Almost like looks like a wash basin to me, where it's curved in a very beautiful manner. Now choose your reference. I will choose this point itself as my reference. So I'm choosing this point or this line as my reference. And now let's write down the Bernoulli's equation. So P1 plus rho g h1 plus half rho v1 square is equal to P2 plus rho g h2 plus half rho v2 square. This is our equation. Let's start writing down each term. Pressure on the top, P1, I think it is the atmospheric pressure. So it will be just P naught. It will be just P naught, guys, nothing else. Then from this reference line, how high is the center of that cross section? It is at a height of small h. So it will be rho g h. Oh, I missed that square here. Plus half rho v1 square is equal to, what is v1? v1 is the speed with which this comes down. So v1 is the speed with which that liquid comes down. Okay. P2 is the pressure here. Think, when the liquid is coming out here, it's being exposed to the atmosphere. So the pressure at this point, because the liquid is moving in a pipe which is made of the atmosphere. Think about it. The stream of liquid is moving in a tube made of air. You can think of it. So the pressure on it is nothing but the atmospheric pressure. So that's why P2 will be P naught. The height H2 will be 0 because it is on the reference line, and it will be just half rho V square because V2 has been assumed to be V. Now P naught cancels, rho also cancels, and I will get GH plus V1 square by 2 is equal to V square by 2. But I can take this term on the other side and see what happens. So this will become V square by 2 minus V1 square by 2. Now here is the interesting part. Look at this assumption. This area is much larger than this area. So if that is true, you know what is going to happen? Think about it. If this area is much larger than A, then if you use equation of continuity, A into V1 is small a into V, you can clearly see, because this A is very large, this V1 will be very small as compared to small v. So that velocity is going to be very small, guys. That means the square of it will be even smaller than this velocity. So I can just say that this is negligible in front of this guy, and I can say approximately this equation will hold true because this is going to be negligible, and therefore I can say V is equal to root 2 GH. This is the formula. Very important formula. Okay, very important. I hope you have noted it down. Why we take reference as this line? Because it is convenient. That's why. If you could have taken other thing also, you would have still got the same answer, but then it would look little bit tedious. So that's why I chose a very convenient reference line. KK, you can ping me on Instagram. I'll help you out. Okay. Noted? Alrighty. Now let's do the next part of this problem. So the next part of the problem will be, how much time will it take to fall down doesn't it look like a horizontal projectile problem? So this t should be the time of flight of horizontal projectile from a hill. So from a hill, if you throw something, how much time it takes to fall down? That's exactly the same time. So this time will be root of 2. This height will be capital H minus small h. So be careful about that. Capital H minus small h by g. So that's the time for which it falls down. Yes, kinematics is everywhere. Yes, it looks very similar. Now once you know the time of flight and the velocity, you can also get to the range. First of all, block this result. Remember this. This is like projectile motion only. There is nothing great about it. Alright. Now let's go to the range of the projectile. So guys, the range. Alright. So the range will be horizontal velocity. Horizontal velocity multiplied by the time of flight. So time of flight in the x direction. So time of flight. So it will be nothing but root of 2gh multiplied by root of 2h minus h by g. Now think about it. G gets cancelled and you will get 2 root h into h minus h. This is what the range comes out to be. You're supposed to remember this formula. Very important. H into h minus h. H into h minus h. Now, if you have now memorized this formula, a very important trick which will be helping you. Think about it. If there is a container, okay, let's say the height is 10 meters. Okay, the height of that container is 10 meters. If I drill a hole here, which is 2 meters from the top, then think about it. This small h will be 2 and capital H minus small h will be 8, correct? Small h will be 2, capital H minus h will be 8. But if I drill a hole here, which is 8 meters from the top, then small h will be 8 and h minus h will be 2. But their product, what will happen to their product? Their product will be the same. What does it mean? Think about it. The range will be the same, guys. Both of them will fall at the same point. Very important thing. Very important thing. Remember, small h is always measured from the top. So 2 into h minus h, 10 minus 2 is 8. 2 into 8 is same as 8 into 2. So if you drill a hole 8 meters from the top below, so 8 into 2 is same as 2 into 8, one and the same thing. Understood? So very interesting trick and a lot of you have got it now. Now this also means just what I have shown over here. If you are at two equidistant points from the center, the range is the same. Was this property repeated somewhere? I think so, in projectile. For complementary angles, the range is same. Remember. So same thing for heights above and below the center line, the ranges are same. Alright. So now, if this is understood, one last thing. When will the range be maximum? So guys, the range is maximum when you drill the hole exactly at middle. So the range is maximum when this is exactly at the midpoint. So very, very important. So from the top layer to the bottom layer, you drill a hole here, the range will be maximum. Very important. Correct. So anything else, you will see the range will be less or more. So if you drill a hole here, it will be falling like this. And if you drill a hole here somewhere, then you will see it will fall here like this. Okay? So the range will be same for any other heights which are equally spaced from the midpoint, and it will be less than the maximum range. So that's how it will look like. So a lot of important things coming up here. All right. Okay. Now let's see if you can get to this question. in a lift which is at rest, a hole has been drilled in a container, and you see that the liquid falls at some distance r from the base of the container. So the range is r. Now if the lift starts accelerating upwards, the range will be more than r, less than r, or will it be equal to r? Come on guys. Yes, honey, root 2 into root 2 will be 2. So that's why the 2 came outside, right? Okay, a lot of you are saying B, some of you are saying C. Alrighty, let's have a look. The correct answer is, or most of you are wrong, the correct answer is C. Guys, the correct answer is C. Be careful. And let me remind you, the formula for range was 2 root small h into h minus h. Is there G in the range formula? No, right? What will happen when it goes up? The G value will change, correct? The effective gravity will become G plus A, where A is the acceleration of the lift. But where is G in the formula? There is no G. Hence the answer will be unchanged. Now you'll be like, no sir, I'm not convinced. What the hell? I thought if it goes up, then the speed will be more. Yes, you are correct. The speed, instead of being smaller, it will be much higher. So like, sir, if the speed is higher, obviously the range should increase. No. Guys, think once more. The time of flight will also reduce because G is more, so it will fall down also very quickly. So they compensate. They compensate. I hope this is clear. Understood, guys? So very, very interesting problem. This kind of questions can definitely come in your NEET, in your JEE Mains, in CET, BitSat, definitely, and a lot of you are going to get this wrong. So that's where, you know, the people who think properly, cool-mindedly will get marks. So that's why I'm training you so that you also get those marks. All right. So let's get going. Let's get going. Now this is such a beautiful problem, and this problem has been solved by such ridiculous, such random and such lengthy methods in so many books and by so many people. I really don't like it. We are going to solve this problem in a very beautiful way. Okay, so here is the thing, guys. There are two liquids. One liquid is 2 rho, other liquid is rho. This liquid has been filled till a height of 3h. The upper liquid has been filled till a height of 2h. The question is, where should the hole be drilled so that the range is maximum? Now we all know that the range is maximum when you drill the hole at the midpoint, but that is only true when the liquid inside is the same. But here, that's the problem. The problem is that the liquids over here are different, and this problem came in JEE Advanced, guys. And it was there like an integer kind of question, I think. But I've changed the values. I've not kept the values same. I've changed it to some different values of density and height. The question over here is to figure out where should I drill the hole so that the density is maximum. Now a lot of people use some stupid Bernoulli's equation and all that, and they got the answer, no doubt, but it is so lengthy. But do you really think in JEE Advanced as well you will have so much of time? No, right? So let's see how to do this problem. So the trick is, guys, the trick is to convert these two liquids into one single liquid. We can convert these two liquids into one single liquid, but you'll be like, sir, how do we do that? Here is the fact, a simple thing. This liquid which is there on the top, it's creating some pressure on the liquid which is below it. What if I convert the liquid on the top, whose density is rho, into another liquid whose density is 2 rho? If I convert this liquid into a liquid of density 2 rho, then it will look like one single liquid. Then you will be like, huh sir, done then. No, it's not so simple. You can't just write 2 rho here, because then a liquid of higher density will create more pressure. So when you write it as 2 rho, it should create the same effect as the liquid of density rho. How do we do that? Think about it. I can't just write 2 rho over here. Think, what should I do? Change the height. Change the height. No, don't stare at Dinesh. Change the height. Yes. How do you change the height? Think. Liquid of density rho, height 2h will produce the same effect as a liquid of density 2 rho, but not height h. Think about it. Think about it. Think about it. Yes, it should be half the height. Correct. It should be half the height. Exactly. Instead of 2h, make it h. Why? Because the density was doubled, so height should be halved. If this density was converted into 3 rho, then that height should be divided into 1/3. That's how it is. I hope this is very clear. Okay, so convert this liquid into a liquid of height h. Now it looks like one homogeneous liquid whose height is nothing but 4h. So 4h is the total container's height, total liquid's height. Where will I drill the hole? Obviously that hole should be drilled for maximum range exactly at a height of 2h. So where is 2h over here? Here, like this. So drill the hole at 2h and that's the answer. How simple it was. Yes, 17s. Height will be inversely proportional to density to maintain the same effect. Correct. Yes, Chinmay, you can do both of them. Shreyas, Rajnik and Halliday is good if you are studying for Olympiads, not for JEE so much. Okay? And I have kept a special lecture only for books. In fact, I think Shimon sir also took a lecture for which books to use, etc. So please watch that lecture where we have exclusively discussed which books to use, how to study, etc. Okay. Great. Now, why I did not add density? Saurav, why should I add density? Density is, why will it get added? It's same liquid, right? It's converted into one liquid. So that's why it's looking like one simple liquid. So that's why 2 rho. Okay. Now, let's go to another interesting thing, guys. And that is basically a method called as siphoning, or a device called as a siphon. Now, if you ever have cleaned the tank overhead, or if you have cleaned the fish tank, then obviously if you want to clean up the water inside the fish tank, you obviously do not do this. You take out the fish tank and then make it upside down and then clean it. No, you do not do that. So what is the way to remove the water from the fish tank? Because it's very delicate. You can probably lose control. It might slip and it might just fall down and break. So now understand, this method of a siphon is used to remove water from a higher height to a lower height. But understand, the problem is that we all know that liquid will easily flow from top to bottom. Okay, liquid will easily flow from top to bottom. But imagine there is no straight path from top to bottom. First, the liquid has to go on the top and then it has to go on the bottom. So how will this liquid ever know that actually after I cross this hurdle, you are going to reach over here? Alright, this liquid over here does not know that if it crosses the hurdle, then it can reach over here. So it looks like simple thing, yeah, it is going from higher to lower potential, but how will it know? This is exactly like how your preparation phase is. So when you just begin your JEE or any examination, NEET examination preparation, so this is where you are. This is your hurdle. This is your everyday studies. Everyday studies, everyday attending the classes, everyday staying motivated, solving lots of problems, not getting distracted. All those hurdles are there, a lot of distractions. So once you overcome it, it is a free-flowing thing. You will definitely become a winner, guys. So let's see how do we do that. It's very simple, guys. What you do is first put the complete pipe inside the liquid of that fish tank. So put it over there. Now make sure that the water is completely filled inside, right? So make sure that the water is completely filled inside. Now slowly take the pipe outside. The tank. One end is inside the fish tank. The other end is in your mouth. Okay. So suck that water. Yes, suck that water, but do not drink that water. Please don't drink that water. Just make sure it reaches here, and when it reaches here, then stop it. Okay, please don't drink it, else you'll be drinking a lot of weird shit. All right, so once it comes here, then leave it, release it. You will see that the water will continuously flow. What has happened, guys? What has happened? Basically, once the liquid has been sucked, all right, it reaches here. Now this water knows, oh, there is low potential here. Now it will tell the next water, hey, you know what, there is low potential energy here. This will tell the next piece of water, hey, you know what, low potential energy here. It will communicate. Just think of it as if it is communicating. So that's why the liquid gets sucked into the pipe till the bottom, and this will continuously happen because the liquid particles are touching each other here continuously. That is very important. All right. So here is the reason now. Now that you know why this works, you can try it out next time. Remember that you need to initiate it. So we teachers out here are basically the people who basically pull you up through this hurdle so that you at least see, bhai, there is lower potential energy here. Come on, move it now. All right. Okay. So let's get going then. Let's get going and see how to solve this problem. What is the maximum height for which the siphon works? What is the speed of the water over here? So there is a tank on the top, heights have been mentioned. There is a maximum limit till which you can take it on the top. Beyond that, the siphon won't work. And then when it comes down, what is the speed, guys? So that's the question. So let's see, how do we solve it? How do we solve it? All right, so here is the thing. First, somebody was asking, is H.C. Verma the successor of Resnick and Halliday? Well, they are two independent books. Some people might have told it that it is the successor of Halliday and Resnick. It's different views, different people. They are two very good books. Halliday and Resnick is excellent book. Even H.C. Verma is a very good book. But each book has its own purpose. It's up to you, whichever book you want to follow, you are free to follow. Just clear the exam and you understand the concept. That's all I need. All right, so it's up to you. I hope, Sakshi, I have answered your question. Okay, so understand, guys, if the liquid has to cross this hurdle point, why is there a limitation on the height? The limitation on the height is because probably the pressure at this point might reach some critical value which it should not. You'll be like, sir, how? Don't worry, I'll explain. So first, take this cross section and take this cross section and just visualize the streamlines of the fluid entering this pipe like this. Okay, these streamlines are going like this over here. Okay, so I'm not drawing all the streamlines, but I hope you are able to visualize this. Okay, now this is my cross section number 2, this is my cross section number 1, and let me take this line itself as my reference line. So this is my reference line. I'll measure everything with respect to that. So here is the thing, P1 plus rho g h1, that's our Bernoulli's equation, plus half rho v1 square is equal to P2 plus rho g h2 plus half rho v2 square. This is a Bernoulli's equation. Let's start applying it. So P1 is open to the atmosphere, so I can just call it as P0 plus rho g h1. Since this is a reference line, convenience purpose, h1 is 0 because you are lying on the reference, plus half rho v1 square. This is going to be very small, guys. Why is this velocity going to be very small? This v1 will be very small because it will be moving very slowly. This area is going to be generally very large. The tube area will be very small. So that's why the rate at which the liquid comes down will be very small. You have to wait for a few minutes or hours for it to come down. So that's why this is negligible. P2, I do not know what is the pressure at this point because it is not open to the atmosphere, plus rho g h2. H2 is nothing but h. So rho g h plus, okay, half rho v square. This is what I got. Plus half rho v square. I hope everybody is able to understand this point. Now rho cancels, half is not cancelling, but here at least I got P naught is equal to P2 plus rho GH plus half rho V square, isn't it? Now, okay, rho has not actually cancelled, guys, my bad, it is still there, okay, at least in these two terms. Now the critical case is that exactly, Kirito, just like you hit on the nail. So here is the thing, this pressure is less than P naught. Why is it less than P naught? Because there are these extra terms here. So if you go up further, rho GH will increase, P2 will decrease, P2 will start coming down. So here is the logic behind it. If H increases, P2 will decrease, and maybe even this speed with which the liquid flows will also decrease. In the limiting case, what will happen? The pressure has almost become zero, this has become max height, and the liquid is barely flowing, hardly any speed. So the pressure is almost zero, the height is maximum, and velocity is barely anything. So then what will happen, guys? You will get P naught is equal to rho GH. Now P naught's value is 10 to the power 5 in SI, 10 to the power 3 is density, G is 10 into H. So H is again 10 meters. So very important value. So this height cannot be more than 10 meters. It won't work anything more than 10 meters. Remember that. So Ranjit, it should become 0 because that's a limiting case. Because imagine you're taking it so high, the water is barely able to flow. Barely able to flow. So that's why the velocity has reduced. And the pressure has almost become 0. Because remember, the sum of all of them should remain constant. So if this increases, the other two should decrease. Yes, KK. There is Bernoulli's principle, there is Pascal's law, there is equation of continuity. Everything is there, KK. When heart pumps the blood, understand there is pressure by the heart. That pressure will flow, and there are so many blood vessels. So equation of continuity is there. Then also Bernoulli's, everything is there. Yes. All right. Now, if the second part demands what is the speed of the water, then it's very simple, guys. If this velocity is asked, all you need is think of this pipe which is going up and down like that. It is kind of useless. Is as good as saying the pipe comes out from this liquid like this, and this point is 5 meters below. These two diagrams are almost equivalent, guys. So these two diagrams are equivalent. There is nothing great about it. And then all you need is how much below is the opening from the level of the water. If you know that, you can directly use the formula V is root of 2GH. That's it. If you know that formula, that's it, you will get it. And root of 2 into 10 into 5, so 20 into 500, so it will be 10 meters per second. So that's how this works. That's how this works. Okay, so you can directly use this. There is no use if the pipe goes up and down like that. There is no use of that. All right, so remember it. Okay, so let's get going, guys. Now I'm going to show you a very interesting thing. Very interesting thing. Why do aeroplanes fly? See, the weight of the aeroplane is lot. It's in tons. The forward thrust comes because of the engines. So the engines blow the air backwards. So that's why the aeroplane moves ahead. But why does it go up? There is a reason for that, and the reason is the lift. Now who creates that lift? Because no air is being pushed down like a helicopter. So who creates that lift? That lift happens because of the shape of the wings, and the shape of the wings is such that it creates the lift. So the shape of the wings is such that the stream of air which comes from the opposite side gets divided into two parts. The one flowing from below, the black one, and the one which is shown in red is going from the top. Now, Just remember Bernoulli's principle, guys. Bernoulli's principle said pressure plus rho GH plus half rho V square is nothing but constant. Now the height is not changing so much, it's negligible, so just forget this term. Just forget this term. If at certain points the velocity of the liquid is more, what will happen to the pressure? Pressure will be less. If pressure is more, then the velocity will be less. They go opposite. Wherever speed is more, that's where the pressure is less. Wherever speed is less, that's where the pressure is more. This is what Bernoulli tells us. So now, if you have understood this concept, think about it. In order to create that lift, what should happen? You should have a higher pressure from the bottom and you should have low pressure from the top. So if you want low pressure from the top, that means the speed of the air moving from the top should be high. So the red one should be really fast and the black one should be really slow so that it creates high pressure. And that's what happens. The fast moving air, when speed is more, according to Bernoulli, creates less pressure, but the slow moving air will create higher pressure that creates that lift. And only this is responsible for balancing the weight of your heavy aircraft, nothing else. Just this velocity difference. If these velocities were not different, the plane won't be able to take off. So basically look at the Bernoulli's equation. Pressure plus half rho V square is constant. So now think naturally, wherever speed is more, what will happen? The pressure will be less. That's all. So the shape is designed in such a way that the wind which flows from the top moves fast. Okay? Great. All right. Let's get going then. Another important principle called as the Magnus effect. When you spin a ball, you will see that it bends. Now why does it bend? Let's have a look at it. Okay, just 1 second, guys. Okay, so when a ball spins, what exactly is happening? So since this ball is spinning like this, all right, so since it is spinning like this, what is happening is that if there is air blowing against it, the air which is over here, all right, the air which is over here will be pushed that way, and the air which is over here will be pushed that way. All right, now think about it. Just imagine, guys, you have a ball which is given a spin and you're throwing it like this. Now if you sit on the ball and observe the air coming towards you, all right, if you see the air coming towards you, this is what you're going to see. Look at that. The air which is coming towards you on one side will be pushed faster, but on the other side will be slowed down because of the spin of the ball. Now the part of the air which is pushed with a higher speed, that's where the pressure will be low. And the part of the air which is slowed down because of the spin of the ball, that's where the pressure will be high. So what will happen? On one side you have high pressure, on the other side you have low pressure. So the moment there is pressure difference, the ball will swing towards one side. I hope this is clear. Spin is because of angular momentum, the impulse and all that. That's different. This is swing. So understand, the swinging effect is created because of this. Exactly by this sort of, whatever I told you, this is called Magnus effect. So you spin the ball like this. So what happens is that when you spin the ball in particular way, the air on one side is slowed down, other side is fastened up a little bit. So the pressure difference creates that movement as if the ball is turning when it is in air only. That's what has happened. I hope this is very, very clear now. Is that clear, everyone? So now, what device is this, guys? What device is this? What device is this? Any guesses? Shreyas, if you want these answers, you can definitely join the pro course. In that there is a special functionality called as the doubt app. So all the doubts can get answered, whatever doubts you have. There is a special team of teachers who sits over there to answer all the doubts, alright? So understand, in these YouTube classes, I cannot randomly take up doubts from random topics. So that's why please use the subscription, join the doubt app, and you can definitely ask all your doubts. Alright, it's some meter, water pump. So Bhavna has got it correct. So yes, it is venturimeter. It is called as a venturimeter. Alright. So guys, what happens in a venturimeter is basically it's a device to measure the speed of liquid flowing through it, or how much liquid per volume per unit time is flowing through it. You can find it out using very simple equations. So what happens is the pipe has a narrow part. You can see that pipe which is there over here. Okay, so that's red color pipe which is there. It has a narrow part and again it expands. So what happens is that narrow part is called as the throat area. Okay, that narrow part is called as the throat area. And when that liquid comes inside with some speed, let's say V1, in the narrower part, the speed increases. Why does the speed increase? Because the area has reduced. Let's say the area of the wider part was capital A, the area of that smaller part was small a. So small a is less than capital A. Now because of that, what will happen is this velocity 2 will be more than velocity 1. Using equation of continuity, a v1 is equal to small a v2. I hope this is very clear. A v1 is equal to small a v2. Now because of this velocity change, you will see even the pressure will change. Over here the pressure is P1, over here the pressure is P2. Now if you use Bernoulli, you can clearly see what will happen to the pressure. P1 plus half rho V1 square, rho GH is 0. Why rho GH is 0? I can take the horizontal line itself as the reference. In that situation, the area of cross section is at the same height. So it has not changed the height if you take this as the reference. So that's why rho GH term is 0 is equal to P2 plus half rho V2 square, again plus 0. Now just rearrange, you will get P1 minus P2 is half rho V2 square minus V1 square. Now from here you can substitute the values. From here you can substitute the values of V1 or V2 over here. The only thing that remains is P1 minus P2. Now think about it, this pressure is more, this pressure is less. The pressure is less because the velocity is more. So because the pressure is less here, because the pressure is more here, if you connect a manometer, remember manometer was used to measure the pressure difference between two gases or two liquids or 2 points. So if you connect a manometer, immediately it will show some height difference. Because this point has higher pressure, it will push the liquid down, and this point the liquid will come out. But the manometer may contain some another liquid, let's say the density is sigma, some other density. So because of that, P1 minus P2 might be sigma GH. So sigma is nothing but the density of the liquid inside the manometer, and that will be half rho V2 square minus V1 square. Now if you connect a manometer and you measure that height, if you know the sigma of the manometer, you know the value of G, you know the density of the liquid flowing in, and you also know the area of the big part and the small part, you can find from all of this V1 as well as V2. That's how you can solve this, and that's how the speed of the liquid flowing inside the pipe is actually measured. Physics lover, why don't you ping me on Instagram? I'll definitely help you out. All right? Is that understood? This is how the speed of the liquid flowing inside the pipe is actually measured. All right, in big factories, companies, and a lot of water stations out there. Okay? So I hope this is very clear. Use these equations to solve it. Please do not by heart. There is one dirty looking formula for manometer. I've seen it. It is there in many books. Don't by heart that formula, because it has never been used directly. You just write the equations, the values are just simple, just substitute, solve the Bernoulli's equation of continuity, you will get the answer. So don't worry about by hearting that formula. Now one last thing, that is the thrust force. Now some of you might have heard it in the news that some people have used water streams, put it on their backpacks, use it like a jet stream, and then crossed some rivers, crossed some seas, crossed from one point to the other. So this is the upcoming new technology where you have a jet pack behind and then you float and then you can go from point A to point B. This is your next kind of transportation which is going to come in the next 100 years maybe, or next 50 years, I don't know. That will be too cool. Yes, just like Iron Man, Navmi, I agree with you. So this is based on a simple principle called as the thrust force. So whenever you have a nozzle and a liquid is being ejected out, it creates a thrust force. So imagine that the area of that nozzle is A, the fluid comes out with speed V, and the density of the fluid is rho. Then the thrust force is given by rho A V square. This is the value of the thrust force. Very important. Now what about the direction? Depends on which object are you talking about. If you talk about this object, which is the nozzle and the body, then on it the thrust force will be here because the water has been pushed there. So by action reaction law, Newton's third law, the force on you will be this side, but on the water will be that side. Remember that. So this is the value of the thrust force. Very important for solving problems. Very important. Okay, now let's see a very cool problem based on thrust force, and then you will get an understanding of how to use thrust force in problems. Very important. Yes, Sweta, why not? This is Flash series where we have tried to cover all the concepts in little bit faster mode. Flash stands for little bit fast. Alright, but it is not like one shot where everything is everything is attempted to cover in one lecture, which is not possible because then you skip a lot of things. So all the concepts are cleared in those playlists chapter wise which I have arranged. Now look at this problem. The fluid which is filled, alright, the liquid comes out from the bottom. Now when the water comes out, it's going to create a thrust force on the container. Because the liquid goes that way, it will create a thrust force this way, and the container would tend to move towards this side. Now there must be some coefficient of friction below, without which the container will start moving. So the question is, find that coefficient of friction. So let's try this out. Let's assume that the liquid inside the container is filled till a height of, let's say, x. This x is some variable. It could be anything. Okay, the liquid from here oozes out with a speed of small v, correct? Because of which now there will be force on that container. The thrust force on that container will be towards this side, correct? The thrust force will be this side because the liquid is going that way, it will push it back this way. And who will balance the thrust force? Obviously there is only one thing which can balance it, and that is friction, static friction. But since the question demands us to find the minimum coefficient of friction, that means the friction has been barely adjusted such that it is on the limiting side, anything less than that value, the container is going to slip. So for finding the limiting value, I will make this as Fs max, because I want to find the least coefficient of friction. Now the other forces are mg and obviously the normal. Now the interesting part, you know what is the interesting part in this question? The normal is not constant. Why? Because x is changing. That means even why is normal not constant? Because m is not constant. M is constantly changing. That's why normal is not changing. That's why Fs max will also change. And thrust force is also not constant, because this velocity depends on this height. Nothing is constant in this problem. That's why it's a crazy looking problem. So it's a very crazy looking problem. So let's do it step by step. You will see after all it's not so crazy. First, think what will be this mass m, guys? This mass will be density into volume. What is the volume of the liquid inside this? The volume of the liquid inside this will be area of cross section, correct? Area of cross section into height, which is x. Alrighty, so I know what is the weight. So m is nothing but rho ax, so into g will give me the weight. Now clearly in the y direction, I can say normal is equal to mg, therefore normal is equal to rho ax into g. Correct? One more thing. What is this value of velocity? We just figured it out in Torricelli's law. If you drill a hole, h is the height from the top surface of the liquid, then the velocity with which it will come out is root 2 gx. So v is root 2 gx. That's the formula for the velocity. We know that. Now think, guys, what will be the situation in x direction? In x direction, the thrust force, correct? The thrust force should be exactly equal to Fs max. But Fs max is mu into n, and thrust force, we just told you, it is rho. Oh, wait a minute. It is rho into small area, because it is coming out from that area, into velocity square. Rho a v square is the thrust force which is being exerted on the container. Yes, Bhavna, it is beneficial for 2021 as well. Now just start substituting the values. Rho a v is root 2 gx, so square it, so it will become 2 gx is equal to mu into n. What is n? It will become rho ax. Now cancel out. Rho gone. Oh, I think I forgot one g. Yes, one g is also there. Rho gone, g gone. Nothing else has gone. So that's why x is also gone. X is also gone. That variable has gone away. That's the best part. Mu will come out to be 2 small a by capital A. That's my final answer. I have found it out. So if mu is equal to 2 small a by capital A, then it will not slip. What an interesting problem. Did you enjoy this problem? And if you have enjoyed this problem, you should smash that like button, guys. Very good. What an interesting problem. So, this is your homework problem for today. Please understand, not many people have posted comments regarding the homework. They have appreciated the video and all that, but many people have not posted the homework problems answer. So that's why I have not yet posted the solution on the Telegram group. So unless you post the answers, be it wrong, be it correct, it doesn't matter. I'm not going to put the solutions up. So beware. This is your homework question for today. For what value of x is the range maximum? Very tricky problem. Yes, sir, please ask. So you guys have to post the answers for the previous video. Tomorrow morning I'll be by the way, the solutions will be posted on the Telegram group. Tomorrow morning I'll be meeting you at 8 o'clock in the morning for the Menti quiz on current electricity. So please revise your concepts, come prepared. There are some really good questions and you need some speed for solving these questions as well. So come prepared for tomorrow's session. And guys, for all the droppers, the crash course link is there below, along with the discount, which is of 20%. So the price comes down to 8,000 rupees. You can use the code SHCC. So check out all the details for the crash course as well after the session ends. And in case you are a new time comer over here, then please do not forget to subscribe to our channel, because you will miss out on the videos. So please hit the subscribe button, and do not forget to smash that like button bottom out there. So hit that like button so that we get all the energy and we get all the enthu for conducting more such amazing sessions. So Saurav, tomorrow it is not possible, but maybe next time. All right. So Jay, I have been taking advanced problems. If you didn't realize, what was the last question? It was an advanced question. Just because I don't tell you that it is an advanced question does not mean it is not an advanced question. So I have been taking, Jay, advanced questions, mains questions, every kind of question. And by the way, let me tell you, Jay, first I want you guys to be prepared for Menti. Lot of people right now are somehow trying to do advanced questions, but without even understanding mains level question. So it's very important that you first clear all the concepts, first learn everything, each and every bit of it, and only then we will go to the highest level of problems. And don't worry, after the mains exam, what am I there for? I'm going to conduct only advanced problems right till the end of your examination, so do not worry about it. Yes, Princey, I'll do that, like I said. Okay, so I'll try to give the Menti quiz later on. Don't worry. Alright, Jack, don't worry, have faith. I'm going to conduct advanced level questions also, but right now I'm keeping it a mix of mains plus advanced, because mains is our priority now. Very important. Okay, great. See you then tomorrow at 8 AM. That's it for today. What a lovely session. Bye bye. Take care. Have fun and take care.